So hey guys, welcome to my channel. Today GeeksforGeeks problem of the day is floor in BST. You are given a BST binary search tree with n number of nodes and value x. Your task is to find greatest value node of the BST which is smaller than or equal to x. When x is smaller than the smallest node of BST, then we have to return -1. Okay, let me explain you the problem. They give us a binary search tree. What is a binary search tree? For a binary search tree, the left child is always less than its parent and its right child is always greater than or having a greater value than parent. Okay, like for these two, 81 is what? Its right child, that's why 81 is what? Greater than 2. For this 81, 42 is less than because 42 its left child, as well as for its right child it's having a greater value 87. So this is called a binary search tree. Now they give us a value x and we have to find the greatest value which is less than or equal to this x. Okay, now in this example we can find a value which is equal to x, like x is equal to 87 and this node data is what? 87. So we can find a value which is equal to x and we consider it as an answer. Suppose this 87 is not present there and instead of 87 they put 88 here. Okay, suppose it's a 88, then we have to find the greatest lesser value than 87. Like what is the greatest lesser value than 87? It's 81, right? Okay, if there is 88, then the greatest value which is less than 87 is what? 81. Okay, so we consider 81 as an answer. So maybe you understand this problem. Okay, let me show you the Python code. Here I take my answer as -1, as well as I declare a function dfs where I am declaring this answer is from outer scope. Okay, if we if the node is null, then we simply return. Now if the node data is less than k, like for this 2, the node data is less than x, that is node data 2 is less than 87, we consider it as our answer. Like we set our answer as node.data and we check, okay, I consider this 2 as my answer. Let's check, can we find something greater? So to find something greater, we have to go where? Like right child. Now I call our DFS in the right child. Okay, else part, if this node data is greater than x, like for this 90, the node data is greater than x. Okay, so for this 90, what do we have to do? We have to check its left child. Like in its left child, we can find a value which is lesser than 90. Maybe this lesser value we can consider it as our answer. So if the data is greater than x, we have to check its left subtree. Okay, else part, this part is where the x is equal to the node data. Like when we can find a data which is equal to the x value, we can't have to find, like we don't have to go its left child or right child, because like for this 87, if I go its right child, we always having a value which is greater than this 87, which I can't consider as my answer, as well as if I go to its left child, which value is always less than the 87, what we don't need, like this, which I don't need, right? So if I find something like which is equal to our x, we simply just put this as our answer and return. Okay, so this is a simple code, and then we call this dfs function from root and just return our answer. Let's compile this code. Okay, it's compiled and run successfully. Let's submit this code. Yeah, it's submitted successfully. Let me show you the Java code. Let's compile it. Yeah, it's running completely fine. So thank you all. That's all for today.